Hi, and welcome to a short interview with Dan Sachs, the keynote speaker of Meeting Embedded 2018. Hello, Dan.
Hello.
So, Dan, there's probably a lot of people which know about Dan Sachs, which is, I've heard today that you're a superhero, that, you've done a lot of things in the history of C++ and C and unembedded. Could you just give an introduction of what you're known for?
I guess I'm best known as a writer and a speaker in C and C++. I started to develop my public presence when I wrote for a number of trade publications, which were widely available in the late 1980s and through the 1990s, most of which are now out of print. I've also made a lot of appearances at technical conferences, C and C++, and embedded systems programming conferences. So a lot of people have been able to listen to me speak on the subject. Interestingly, in those early years, it was very uncommon to make any recordings. So there are actually fairly few YouTube recordings of me available right now, but we're starting to rectify that. I was the secretary of the C++ Standards Committee for the first 7 years, and that was a real learning experience. A lot of my deep knowledge of C++ was acquired during those years. And as far as the embedded, one of the publications I wrote for was Embedded Systems Programming, which became Embedded Systems Design, and what's left is the website embedded.com. I was a columnist for them for 15 years and have started developing training materials for teaching how to use C++ in embedded programming slightly more than 20 years ago. So I've had a fair amount of practice at that.
So Dan, you are the keynote speaker of the first ever Meeting Embedded conference. So what can you tell us about the keynote?
Well, what I'm going to be talking about is my perspectives on the industry, in particular, why it is that I think programmers choose to program in the language that they do. I mean, I think people should be programming in C++, but it appears that C is maintaining a great deal of popularity over C++ in that market. And what is it about the interests of the programmers, the experience of the programmers in that industry that is, I think, leading them to those choices or leading them away from other choices?
Sounds interesting. So if I look at the talks which we have a we have some talks on C++ and embedded, but we have a very wide selection of talks. Actually, if I go to the schedule, it's easier to see. Where we have on continuous integration with C and C++ for embedded, and yeah, your topic there is one talk that they stopped teaching C, and Wouter van Ooyen, a proponent of teaching C++ to students for embedded. Then Rainer is going to talk about core guidelines and other guidelines for embedded. Then we're going to have a talk on code and performance from Daniel Panning, remote procs and Rust. So we have a talk on Rust. So there's also new languages coming to the industry, and there's a new generation of programmers which might not just go into C. And lots of other talks about, one talk even about an Arduino workshop which she prepared, and how mocking works in embedded, and this is an ending with a talk about MQTT, which is actually a new standard out in this year, which is also one of the edges which we touch in embedded often. And at the end, I'm gonna just do a quick half-hour talk on what is embedded, which probably also is an interesting point.
So what is an embedded system? Well, essentially, an embedded system is a computer system that's embedded, one or more computer systems embedded in some larger device such that when you look at it, you say it's that device. You don't say it's a computer. When you look at your wristwatch, you don't say it's a computer, you say it's a watch. When you look at your home entertainment system, You say it's a television set or an audio receiver, it's not a computer. When you look at a car or an airplane, no matter how many processors are in there, you don't say it's a computer. You say it's that device. And I think that's its essential character. In the interesting special case of handheld devices like telephones, that line is very blurry because you can run a word processor on your phone. You can run a spreadsheet on your phone. It's arguable as to whether that is an embedded device.
Yeah,
but
that's,
because they're much more like desktop devices in a small form factor.
Yeah, I think
but I really think of an embedded device as something where you don't think its essential nature is that it's a computer, it's some other device. Now,
yeah.
From the perspective of how you program those things, embedded programming is, again, more and more like desktop or workstation programming. I think the fundamental characteristic of embedded programming, well, I guess there may be two. One is that more so with embedded systems than desktop systems or desktop software, there may be real requirements for safety, like medical instruments or flight systems, where when the software screws up, people are injured. And these requirements tend to be much more of a concern in the embedded platform. And the other thing is that embedded systems usually have some physical constraints that you don't commonly see on desktop or workstation systems, like there may be low power requirements or bandwidth requirements or cramped memory or something like that, which becomes an important part of solving the problem of delivering the embedded system.
Yeah, so I've seen lots of opinions on what embedded is and how IoT is connected to it. I talked last year about that with Wouter van Ooyen, and so his opinion is like embedded is like the very small devices mostly. And while we are today actually going into like devices like Raspberry Pi, which also has the ability to connect sensors, etc. And then we have devices which are as strong as a Raspberry Pi but are more closed and have the sensors like in APIs, like mobile phones. So this line is very blurring, and we see like a whole line of new devices and things occurring, and this is just a very dynamic market now where just things are moving, and I think it's a very, very nice time to see how this evolves in the next years, when even sensors come more cheaper and systems become more available which are more advanced. And like think about robotics and just today like socks which are available. And on the other hand, I think it's the pure embedded control area where you basically think automotive or boards, classic industry applications. It's probably not going to change in the next years because it's a very conservative market. So you have both. You have the one world which evolves very fast in the way what silicon allows you. And you have this other industry, which also is very, very much in the C world, which is very conservative and wants to stick with what they have and add just slowly things to it.
Yes, I agree.
You went from C to C++, and this is quite early. Can you describe this transition?
Yes, well, I actually had experience during the 1980s with embedded development in C. And I started learning C++ in the late 1980s. And during the first half of the 1990s, most of the interest in C++ seemed to be in programming PCs. There was real hot competition among the compiler vendors like Microsoft and Borland and Symantec as to who had the hottest C++ compiler. And it appeared that the way that market was going was toward also a lot of interest in user interface design, what ultimately became things like the Microsoft Foundation classes and Mike and Borland's OWL. And I found I had no interest in that kind of programming. But I did notice that the embedded market was still wedded in C. And I thought, gee, it looks like there are some interesting problems in that domain. And I just sort of started dabbling there and using my C knowledge and my knowledge of the C++ language and combine them to really start experimenting on my own and developing lectures, which I presented at the Embedded Systems Conference on. If I were doing embedded programming, this is the portion of C++ that I would be using. And gradually, people started paying attention to that. And I got involved more with people in that market in a real way and got to get feedback on the techniques that I was advocating from people who were actually trying to apply them. And through that feedback loop, developed what I think is a fair understanding of how C++ should be used in an embedded environment.
Interesting. And during that time, you also were one of the first members of the C++ committee, if I understand right.
Right. Yeah. I was at the founding meeting, and I was the secretary during the first 7 years, and so I had to pay attention. And I picked up an awful lot of stuff about details of the C++ language, especially the core language, which I think was most applicable in the embedded market in those early years.
Interesting that actually the roots of C++ are from the embedded field often. That's really interesting. Today the situation is interesting, and the market is actually moving towards C++ and C++ 14. The latest AUTOSAR standard is actually based on C++ 14. So what is your opinion on doing modern C++ for embedded?
Well, I think it's great. I think modern C++ is a better tool for embedded than pre-modern C++ was. In particular, things like const expr I find very valuable. Another one which I'm not sure people notice this one that much, but I think that the underlying type specifier for enumerations is a great leap forward in making them more usable in embedded systems, because
yes, gives you more control.
Yeah, a common complaint with enumerations previously was that in embedded applications where you had to have pretty precise control over the size and alignment of your objects, you couldn't do that with enumeration types because the storage layout and the underlying type was implementation defined. And now you can control it explicitly, which makes them much more suitable for all sorts of uses inside sensitive data layout like packet communication packets, or even in memory mapped registers. What else have we found to be valuable? I should have consulted my notes on that, because I've just overhauled my
what I have seen from folks like Odin Holmes, who is really doing a lot of work in this field. It's very practical to have constant expressions check and validate your assumptions, so that
right.
Certain input ranges are actually guaranteed during compile time, and on the other hand, that certain programming errors are able to be catched at compile time. So you don't have a runtime error, you have a compile time error. You're not even going to the device. And I think if you go into the newer standards, there's even more like this, definitely being able to select easier ways in doing template metaprogramming in a way that actually decays into code that is usable for embedded. Not saying all templates are good for embedded, and I know that the SDL probably still is for most embedded projects a no-go, but there's a lot of features in the language now which makes it able to write your code in C++ and enhance your code in C++ in a way that adds really value which isn't available in C. So you actually can do a lot of things in C++ now and make certain checks at compile time, and this is like a really important feature.
Right. The couple other things that I have found valuable, although they are in C as well, is the static assertions are really good, and the type traits in combination with static assertions are really useful for turning what would have been a runtime error into a compile time error.
Dan, I know that there's a few changes happened in your career where you moved on or did different things. One of the big things is like currently you're still doing is doing trainings and being a trainer in C++. So this is your website.
What am I doing today? Well, my business is primarily training, and in particular, it's training embedded developers, mostly who are using C and want to make the transition into C++. And so spending a lot of time now on course development and moving a lot of what was our traditional C++ training into modern C++. We're finding that the tool chains for embedded development are finally catching up and supporting C++ 11, at least on a wide scale. And so we've been going through some massive upgrades on this. And when I say we, I'm working in cooperation with my son, Ben, who joined my company a year ago and is actually gradually taking the lead on integrating modern C++ features into our curriculum.
That sounds like a great job to do, to be father and son, and just to be able to update the material into the modern age.
Right.
So, what's your experience with the folks you train? How do they kind of receive the new world they are suddenly able to use coming from C?
It ranges from some people who are really enthusiastic about this. They're just, in fact, but even the real enthusiastic people, I find, have a somewhat conflicted emotional reaction, because it's not uncommon for them to say, this looks really great and I'm looking forward to using it, but my code base isn't up to it yet. I've still got massive portions of my code base that are still being compiled in C. And we have to go through the transition of at least recompiling it in C++ before I can even think about starting to use some of this stuff. There are others who the reluctance is that despite the effort that I place into trying to show them that it's not that mysterious as to what's happening under the hood with most C++ features, there is this concern about how much harder is this going to be to debug, that they're afraid of what they will see when they start to really snake their way through the code using a debugger. And this is one of the ongoing issues that I face, is to try to teach people that, well, what you want to do is really wean yourself away from the debugger. You want to put a heavier reliance on the type system and what you can do with static analysis to turn as many of the potential runtime errors into compile time errors. Now, the problem is that's never going to be perfect. There will always be in my lifetime, there will be a role for the debugger. And so you can't allay that fear entirely, but I think you can make a lot of inroads by really developing an appreciation for the improved type system in C++.
Yeah, I heard that some part of the C community really sees the debugger as a development tool. So it's kind of for them the way to understand their programs and to evolve their programs. And in C++, that is not a thing, which I haven't heard that from a C++ developer. So that's actually interesting. And yeah, this is probably a hard change for people which are used to really depend on the debugger and to see it actually as a useful tool. And while in C++, you use a type system and you know your code in a way that you try to avoid using the debugger.
Yeah, but that is a big cultural shift, and it takes um, a lot of a lot of persuasion to get people there.
Dan, thanks for your time, and I really look forward to see you in Berlin. It's almost a month now. Um, so thank you for your time, and
You're most welcome. I'll see you in Berlin.